In the Leveling Computations 1 video, we calculated the HIs and elevations in this benchmark level circuit. Well, if we can make rod reading errors in the field and thus cause problems with our measurement, it's also possible that we could make math blunders. So while we're doing the computations, it makes sense to perform an arithmetic check. So the way we do this is we sum any backsights and foresights that are taken on turning points or benchmarks. See, in this case, all of our backsights are taken on benchmarks or turning points. So we will sum them all. And the sum of these works out to be 24.63. Likewise, we'll sum any foresights that are on turning points or benchmarks. And in our case, they are all on turning points or benchmarks. So in this case, the sum of those is 24.62 feet. Well, according to the procedure that is spelled out on the next page in the Leveling Computations Practice 1 handout, we're going to add the sum of the backsights to the starting elevation and then subtract the foresights. So here's what that looks like. We take our starting elevation, in this case 100.00, and we're going to add 24.63, and we're going to subtract the sum of the backsights, and that result we will compare with what we computed using our HIs and elevations. In this case, these two check. Therefore, we don't have any math errors. However, if they did not agree, then we would investigate for math errors. If we don't have any math errors present and we have some disagreement here, that indicates that we have some rod reading error. Unlike the level circuit on page 1 of your Leveling Computations Practice handout, this one on page 2 begins and ends at separate locations. Here you can see the beginning of the circuit is at benchmark B and it ends at benchmark C. Clearly they have two different elevations. We start with 792.04 and the known elevation of benchmark C based on previous surveys is 782.65. So therefore this is what we call a connecting benchmark circuit. Along the way we'll be determining the elevation of a new benchmark E, which is unknown to us at this point. Well, the process is the same as what we saw before. So we're simply going to add backsights to elevations to get HIs and subtract foresights from HIs to get elevations. So here you can see the final elevation that we computed for benchmark C agrees within 0.02 of the original elevation. Let's do the arithmetic check quickly here just to make sure we are seeing what we should see. That is, we have not had any math blunders. Here I get 22.46, 22, and I get 3187. 3187. So as we said before, we're going to take our starting elevation 792.04, 792.04, and I'm going to add 2246, and I'm going to subtract 3187. Okay, 2246 was the backsights. 3187 was the foresights. And when I crunch that out, let's see what we get. And indeed, I get 782.63. 782.63. That matches what I have up here, so that means I don't have any math errors in this case. Now, one other thing that we've alluded to already, but we have not actually shown, is this closure error. So we're going to take the computed closing elevation minus our known closing elevation. So in this case, it works out to be 782.63 minus 782.65, and that equals a negative 0.02. That closure error is this difference between what we computed and what it's known to be. Please notice that the arithmetic check in this case on this circuit has a sum of foresights and a sum of backsights that are wildly different. Why? Because the circuit starts and ends in two different places. When you're looking at a circuit that ends and begins in the same place like we saw with the first one, then those two sums will be very, very similar. Okay, so hopefully this helps you understand the basic computation process. As we get into profile leveling, you will see some variations on this, but the concepts certainly cross over.